All right, so our last presenter for the period is Mr. Jeff Lundberg. He has been with Hitachi Data Systems for 8 years as a senior product marketing manager for object storage and data mobility. He holds a Bachelor of Science degree from Santa Clara University, is a veteran of both Veritas Software and HP with 15 plus years of experience in cloud archiving, data protection, information lifecycle management, and end user file services and object storage. I know all those words. I'm not entirely sure I'm sure about those words now.
Neither am I.
Please give a warm welcome to Mr. Lundberg.
Thanks all, and thanks for spending a few minutes with me today, and happy to help get you out of your regularly scheduled class programming. I don't want to necessarily talk too much about Hitachi Data Systems itself. What I want to kind of touch on is some stuff that's going on in the industries that we serve, which is really kind of everybody. If you look at Hitachi at the highest level, it's a multi-industry conglomerate, right? We make video cameras, televisions, projectors that are doing this, medical equipment, train services, et cetera, et cetera. But what we're really trying to service as a data company, not so much a IT company, is this idea of digital transformation, right? So when you look at companies like Uber, like Airbnb, like Tesla, what they've done is they've really disrupted a lot of traditional industries that are out there today. Look at Uber versus taxi cabs, right? Taxi cab, you stand around, you hope one comes by, or you call one and they'll be there in 15, 20 minutes if you're lucky. With Uber, right, it's a website. It's an app on your phone. You ask for a car, the closest one gets sent to you, it picks you up, it takes you where you want to go. You've heard a lot of probably fights over the news and so on and so forth here in Portland about Uber and how they, are sort of disrupting the way that taxi industry works. You look at companies like Airbnb, right? Do I want to stay in a hotel? Do I want to stay in somebody's house? What's the easiest way to book that, etc.? Think about, in the context of Airbnb, think about, the trade embargo being lifted in Cuba. If I want to go and stay in Cuba, I can get on Airbnb, book a house, go stay there. If Marriott or Hyatt or somebody wants to open a hotel there, they have to get permits, they have to build a hotel for a couple of years. It's going to cost them several $100 million. Airbnb turns on a web page, right? They market it a little bit. If that trade embargo goes back into place, those traditional hotel-based companies, they're stuck. They've got $300 million worth of assets there. They can't just pick it up and move it. Airbnb turns off a few widgets on their website. You can't book in Cuba anymore, right? And they do this with a handful of engineers. So it's a very different model of delivering the same type of goods or services to you, the consumer, but it's doing it with much less overhead because of technologies like the cloud. Right? I don't have to have these gigantic data centers with racks and racks of computers and switches and storage and cooling and power and floor space, et cetera, et cetera. I go to somebody like Amazon, I say I need 5 computers with this amount of storage. If I need more, I ask them for a little bit more, and then I pay them for that little bit more. I don't have to buy another 10,000 square foot data center, staff it with people, put in all the utilities, et cetera, et cetera. Then we look at somebody like Tesla. Right? They're not just disrupting sort of the traditional gas automobile industry with their electronic drive, but they're bringing in things like autonomic driving, right? So now if I have, say, a Tesla car, I can drive it to work in the morning. If it drives itself, I could have, an Uber account and say, well, I'm going to be at work for the next 4 hours. Tesla car, go off. Run a couple of routes for me, make me a little money, come back here at noon because I want to go to lunch. When I get back from lunch, put it back on Uber, it drives around, makes you a little more money, and comes back and gets you when it's time to go home. So there's a lot of very big changes coming to the world as we know it, not just IT. And you're in a great position now because a lot of this stuff is just kind of getting started, right? So continue to focus on technology, right? Learn about these types of systems. See what kinds of opportunities interest you, whether it's robotics or artificial intelligence, right? You think about a self-driving car, that's both. It's a robot with artificial intelligence. It drives around, it knows the map, the route that it wants to go, but it can go and access a service like Waze and know where the traffic is and find the best route. It can avoid the dog that runs across the street and doesn't, drive onto the sidewalk and crash into a bunch of people. There's also this idea of the Internet of Things. Right? You may have heard the term IoT, Internet of Things, etc. What this essentially is it's putting computers into everything that you own. Not just your smartphone, not just your tablet or your laptop, the thermostat in your house, the refrigerator. If there's an RFID tag, radio frequency identification device, if I put those RFID tags into things like a carton of milk, it knows when that carton is empty or when it's expired. It can call up Amazon when it's running low and have that new box of milk on your front door the next morning when you need it, right? And that's all part of, a smart fridge that can read those tags, be connected to the internet, make those orders for you. You put it in your shopping list and it just shows up one day, right? These are the kinds of things that are already starting to happen today. And it's this merge of bringing together what's, we all know as informational technology with operational technology. So at Hitachi, because we make pretty much a little bit of everything, right? If you go out to any of the big construction sites around here, you'll probably see a Hitachi earth mover of some kind. You may see video cameras, projectors, et cetera, et cetera. We've been doing that kind of work, obviously breaking projectors, for a long time, right? Over 100 years, Hitachi's been involved in trains and medical technology, industrial bits, all kinds of different things, even car stereos, right? All the way across the line. But we bring that together with over 50 years of information technology experience in data center technologies, consumer electronics, et cetera, to really bring these two worlds together. And not just in the way that, we can enable this kind of transformation, but to derive insight from the data that's coming from all those devices. So if I have a bulldozer at a construction site, it's got hundreds of sensors in it around the hydraulic system, the transmission, et cetera, I can monitor those in real time. I can know when a part is about to fail. I can have that maintenance take place in a predictive way so that it doesn't go down in the middle of a job site. Right? I can bring a replacement device out, bring the other one in, get it repainted, or fix the hydraulic system, add more fluid to wherever it needs to be, so that all that stuff stays up and operational, the job doesn't have to stop. So this gets you then into discussions like big data. Everybody kind of roughly familiar, or at least heard the term big data? What this means is all those sensors, all those consumer devices, all those industrial devices, they generate thousands of bits of data every second, and they send those over networks and over into the cloud and into these big storage data systems. All that stuff, that's a huge amount of data, right? We all know we've got, gigabytes of data on our phone. We maybe have terabyte drives on our laptops. We're talking orders thousands of times greater than that. Today, a lot of companies are dealing with what we call petabytes of data. That's the next step up from the terabyte. But really what we're looking at overall are things like exabytes. Thousands and thousands of times more data than we can even really imagine. And this is getting generated every single year. And this is why technologies like cloud are so important, because not every company can build a data center big enough to store all of that data. So I need somebody like an Amazon, like a Google, like a Microsoft, who can invest huge amounts of capital in building these vast data centers to store all of that information. But that comes at a cost, right? It's not free. Yes, you can get free storage from people like Dropbox and Google, et cetera. But once you hit a certain size, you got to start paying for that. And that's because they have to do a lot of the back-end stuff that none of us see when we interact with those services. There's a reason why your data is always available, why it doesn't get lost. And it's not just because they have some magical sauce in the mix. It's because they have more than one data center. And they make copies of that data across different data centers. And they can put it in different countries or regions, and they can break it up in the right way to move it around. And it's very complicated, and that's why, a lot of companies turn to things like cloud services so that they don't have to do all of the blocking and tackling and keeping the lights on and everything else. And that's what allows companies like Uber to grow up and challenge things like taxi services that have been around for hundreds of years. The only way they could scale that and have, maybe 10 to 15 engineers is because they don't have to have a big data center. All that work happens somewhere else. They focus on writing the code, developing the application, the thing that actually delivers the value to their customers, not building and maintaining an IT infrastructure. My slides are too big. There we go. But it goes beyond just kind of the profit motive, right? It's not just about making more money for a particular customer or a set of shareholders. A lot of our technologies end up in places like state governments, right? Public safety. How can we put a set of systems in place in a city to do things like gunshot detection, right? Microphones all over the place. They pick up that spike of sound. All of a sudden, all the various cameras in that area turn towards that noise, and they're looking for, a speeding car or running individual. Facial recognition software gets applied to look at that area to see if there's somebody there matches a description from a 911 call. These all used to be very different systems, and it took a long time to go in and do the research, do the discovery, do the forensic analysis of this stuff. But if we can bring it all in a common way, associate certain attributes to it, right? The gunshot detectors at these different latitude and longitude coordinates detected it. We can triangulate roughly where it went, where the gunshot originated. Here's all the different state-owned as well as private registered cameras in that area. We'll collect all that video data. We'll tag it with the right time print, right? We know when that happened. So if we look roughly in those 5 minutes or so around that time frame, look for a speeding car, look for somebody that matches the description, you can then track that back through other systems, try to come up with an identification of that individual. And if you do that enough over time, you can start to map out where those types of incidences are more likely to occur. So you can say, it could be as simple as, lots of cars get broken into in this zip code, so we're going to charge more for insurance policies in that area. Or it could be, we're seeing a spike of petty theft in this particular area. Maybe we'll have more patrol cars drive around. Not to necessarily catch anybody, but just to have more presence there to try to deter that criminal from repeating that activity. And it could be even something mundane, right? We have a state government on the East Coast. They fly drones over their roadways looking for potholes. They find the pothole, the drone knows where that pothole is, issues a work order to a work crew, they go out, fill the pothole, drone flies back over, sees the potholes filled, closes the work order, pays the contractor. Everything kind of happens in a more automated way. You don't have to have survey crews go out and do all this extra stuff. It's just much more streamlined. So it can be improving public safety, it can be improving the results for the citizens and the taxpayers of that particular area. There we go. So beyond some of those examples, we talked a little bit about the smart city here, but there's a particular project we did with Copenhagen City, and it's basically a data exchange or a data mart. All these organizations can put their data into essentially an online shopping mall of data sets. One of those participants is a construction company, and they were doing subway retrofits in the city of Copenhagen. They have very detailed maps of the underground sections of the city. And they're able to sell that to smaller construction firms who want to do work on a particular building. They don't have to then go do their own surveys. They just buy the data set from the existing stuff that's out there. They can get their permits done a lot more quickly because everybody sees the same set of data. They don't have to send inspectors out and so on and so forth to know, well, we can't put the wall here because then we'll be cutting into the subway system and then a train hits the building and everybody's unhappy. Hitachi is also a big player in healthcare. We make a lot of medical imaging type of technologies, things like proton beam therapy machines, which I don't understand, but it sounds cool, so I like to talk about it. But bottom line there is, again, going back to that sort of predictive maintenance, right? There's a lot of high-tech stuff in these machines. Supercooling systems, ultra-powerful magnets, linear accelerators, and there's, a lot of, not moving parts, but a lot of electronic bits in there that can wear out over time. And those machines are exceptionally expensive, right? We're not talking about an X-ray machine on the order of tens of thousands of dollars. These are $1 million plus machines that take up entire rooms. So if that goes down and you can't have patients going through there that need that therapy and getting paid by the insurance company, you're not really making money. You're not helping your patients achieve the outcome they're looking for. So just by analyzing what's going on in those machines, right, this accelerator is getting out of alignment slightly, we'll send the tech out and fix it before it shoots a proton beam into a piece of sensitive electronics and fries that as well. In the area of rail, as you can see, Hitachi, well, it's kind of washed out there, but that train is a Hitachi train. And we deliver what we call rail as a service in the United Kingdom. This isn't the UK buying our trains and all the systems that support it. They basically pay Hitachi data systems to build, maintain, drive, manage those systems, right? So they don't go out and cut checks for billions of dollars to build all this stuff. They just say, Hitachi, please build us a set of trains, the rails that go along with it, all the computers to manage where those trains are and when they need to be there and their maintenance and everything else. And this is the type of what they call a consumption model that companies are moving to. They don't want to buy everything they need for the next 5 years upfront in one big purchase, a la the cloud, right? We want to buy things as we need them. We want to pay for them as we get value out of them. And to be able to deliver those kinds of services to those customers of that scale takes a very large company to be able to do that. In the world of finance, Hitachi is one of the leading people in the area of blockchain. Kind of an esoteric term right now, but if you think about things like Bitcoin, right, those virtual currencies. Blockchain is kind of what they call a virtual ledger. So instead of having one big computer that's processing all these transactions, it gets distributed across hundreds or thousands of other machines. This makes it much more secure because I don't just go to Nike and be one of those 17,000 people trying to attack a single entity. I would have to be able to attack thousands of different systems at the same time to try to get at one little fragment of financial data. So these are the kinds of transformational technologies that are going to make data a lot more secure and make those transactions happen a lot faster. Right? Because if it goes into one single clearinghouse, that's a bottleneck, right? Everything gets narrowed, it goes through one system. If it's going through thousands of distributed systems, it can happen in a matter of minutes as opposed to 2, 3, 4 days, right? So that's always nice. And then in the areas of public safety, I talked about one of our state governments. There's the city of New York also uses a lot of Hitachi technologies, from the cameras to the encoders to the storage and analytic systems for emergency response and public safety on their waterways. So it's again, changing the way that a lot of organizations and countries and states, et cetera, deliver services to their clients. So why Hitachi in general? Well, not a lot of people necessarily, Hitachi doesn't kind of roll off the tongue, right? You don't see it every day and think about it in the way you think about an Apple or a Microsoft or a Google. But because we're over 100 years old, because we touch so many industries, we have far more patents in a lot of these areas than IBM or Siemens or General Electric. Right? This is a big company with a lot of opportunity. We do over roughly $5.5 billion in the Internet of Things space. Right? So very powerful organization. We invest a lot of money. We have a lot of employees focused on this area. And if you're interested in these kinds of careers, Hitachi is a great place to be. So thank you very much. Enjoy the rest of your day.